All right, so for the scientific notation worksheet, I decided it made more sense to me to sort of walk you through a key in a video rather than post just a key for you guys. So the first part of this worksheet, we are working with this table which shows the diameter of these different planets, or not planets because the moon's not a planet, but these different things and the solar system. And we're looking to figure out some conversions. So the first conversion we need to do is we need to switch from kilometers to meters. So if the moon has a diameter of 3,476 kilometers and we want to convert to meters, well, we know in every kilometer there's 1,000 meters. And when I say we know, it's told to us up in A. So if we use this, we can actually cancel out the kilometers and we're just left with meters. So that's how they got this first step. So for me, I know this isn't our calculator that we have. I don't have one of those to use in this particular on my little tablet, but I can bring up this calculator and kind of show you how you might do this. So even in our calculator, right, we have the ability to change our mode from normal mode to scientific mode. So if I do that, if I were to play with the Earth's diameter here, if I just type in 12,576, it pops out what that is in scientific notation. And if I want to find that diameter, well, I just need to multiply by, in meters, all I need to do is multiply by 1,000. So this tells me that for the Earth, the diameter is, 1.26 times 10 to the 6. I do not like this color. 1.26 times 10 to the 7th. Right? That's what my little calculator said. That little E just means times 10 to the 7th. All right, so the next step that we do after converting our diameter from kilometers to meters is we want to convert our diameter into a radius. So just a reminder about circles. Diameter is the entire length across the circle passing through the center, and the radius is half of that length. So that's our radius, whereas the green line would have been our diameter. So all we need to do to get, for the first step, we multiply by 1,000. For the second step, we divide by 2. So again, if our calculator is already in scientific mode and we already have our answer there, I can just say take that answer and divide by 2. And it tells me that we're looking at now 6.29 times 10 to the 6th. Now you may have slightly different answers on yours, especially if you actually use this rounded version in your steps. If you use this rounded version, you're going to get a slightly different answer here. You'll get 6.2. My brain is slowly, 6.3 without any other decimals. And that's just a fact of rounding a little early. So we are actually, when we use our calculator like this and we keep using the answer, I'm not using the rounded version in any of my calculations, but I am giving out each of my answers to 3 significant figures, or 3 significant digits, which is a very sciencey thing. That means we have 3 numbers in our scientific notation. So the last piece we have here is going to our volume. So we have an equation here. The volume of a sphere is given by 4/3 pi times r cubed. So we have our radius. In order to get, for this last step, from our radius to our volume, we're just going to use this formula. So in my calculator, so I don't have to do any rounding, this piece right here is my radius. So I just want to take that and cube it, right? And then I can multiply by pi and 4/3. Now you'll note I chose to do the cubing first. Multiplication is commutative. It doesn't matter which one I do first, so I would do my cube first, so that way I can keep my unrounded version. And then I can type in times, you guys have a oops, I don't want to double times, my calculator mad at me. You guys have a fraction button, but I don't. So in the graphing calculator, I have to just say 4 divided by 3 is my fraction. And I need to find my pi. Your pi on your calculator is somewhere down here. It actually is a main button, so you don't have to do anything funny. I have pi over here in blue. Oops. So I actually have to do second, and then my caret button gives me a pi. Oh, and if anybody didn't pay attention when I did that cube, I pressed this little up button, this caret button, in the graphing calculator. In the 36X, it actually has a little button that shows you like a square above a number. So it's much easier. So if I do all that work, I get out that my answer is 1.04 times 10 to the 21st. Oh, and I should put units on all of these. My diameter, once I converted from kilometers, was in meters. Radius is still in meters. And volume, I've taken those meters, right, the radius, and cubed it, so we have meters cubed. Cubic meters is how you make up a volume. So you have these little cubes to fill up stuff, right? When you're filling up something, it has to have 3 dimensions. So that's exactly what you're going to do for the other 2 as well. At this point, I suggest you start playing with your calculator, see if you can recreate what I did, and pause the video right now. If you just want the answers, I'm going to write them down now. If you had done the exact same work without the rounding, using your numbers in the calculator like I did, this is what you should have gotten out. I'm sorry, for some reason my pen is being like way more sensitive than usual, and it's all this nonsense around stuff. It's making me upset. 39 times 10 to the 9th. Forgot my units. All right, so we got everything done for this table. The last 2 questions here for this first part of this says how many Earths can fit into Jupiter? And it says just take the volume of Jupiter and divide it by the volume of Earth. So how many little circles? And this is overly simplistic. If you think about how fitting these little circles inside, they're not going to fit perfectly in, right? There's going to be some overlap. Or there's going to be some empty spaces between the circles. So this is sort of like assuming we could take up the Earth, pulverize it so that we didn't have any spaces between these little circles. How many could we fit into Jupiter? So just throwing it out there that technically this question is a little misleading. But they told us they just want us to take the volume of Jupiter, which is that 1.53 times 10 to the 24th meters cubed, and to divide it by the volume of Earth, which was 1.04 times 10 to the 21st meters cubed. So when this is all said and done, those meters cubed will cancel, and we'll just get a number of Earths. So this is where we need to understand how to use the graphing calculator, and not just in the sweet scientific mode. So we need to know how to enter 1.53 times 10 to the 24th. You could do 1.53 times 10 to the 24th. That is possible. The issue here is if you do that, you can't just do this. 1.04 times 10 to the 21st. Because your calculator only sees this division. It doesn't, like, it's going to do PEMDAS. It's going to do the first multiplication, then this division, then this multiplication. It doesn't realize that these things are numbers by themselves. So if you press enter here, you get out a giant number. And I saw some of these on your guys' worksheet. The reason, and if we think about our scientific notation, remember, if you were to do this without a calculator, without scientific notation in your calculator, we know that we would take these 2 powers and subtract them. So we should be looking at something closer to the order of 10 to the 3rd. So the answer here being 10 to the 45th makes no sense at all. I can't divide something and end up way bigger than I originally started. You know, even if the Earth was just 1 meter cubed, this doesn't make sense. So if you're using the times 10 to the, you need to put parentheses around everything. Or even better yet, get used to the calculator's version of scientific notation. So the calculator's version of scientific notation uses this little double E. Oops. The double E. You can see it here above the comma in mine. For your calculators, again, this is a button. It just says this little double capital E. So you'll type in 1.53 second, and then that double, or in your case, just press the double E button. You'll note it only puts 1 E on your screen, and then your power. So this is a shorthand for times 10 to the 24th, and divided by 1.04, and then the little E again, 21. Do not use the lowercase e. That means something different. We'll learn about it later in the class. But this tells your calculator that this is one number. It's all connected, whereas this did not do that, right? So this is actually very useful. So if we press that, now it tells us 1.47 times 10 to the third, which is exactly what we expected. So 1.47 times 10 to the third. And then if you really wanted to put something here, we don't have units. This is how many earths there would be. And this is almost when you're like, well, this would be nicer to have not in scientific notation. So if you think about it, not in scientific notation, we could go out of scientific notation by doing 1, 2, 3. So there is 1, 4, 7. I might even want to get that last digit, 1 earths that we can fit inside of the moon. So we can fit 1,471 earths inside of the Jupiter, sorry. And we're going to do the same thing with the sun. The sun is bigger than Jupiter, so we should be able to fit more earths inside of it. So same exact work, 1.4 times 10 to the 24th, all over 1.04 times 10 to the 21st. Whoa, this is 10 to the 27th. And again, we can immediately see that this should be on the order of 10 to the 6th. So if we get something other than that, we feel really like we might have made a mistake. And we just do the same exact work using our little e. And we get out 1.3, 6 times 10 to the 6th earths. And again, if you really wanted to, you could just write this in its decimal form, the normal format, 136, I guess 13557. I can't keep both these up on the screen at the same time. 55, 769. And I needed 6, so there, I got it. So 1,355,769 earths can fit inside of there. So either of these would be completely okay to me. There's nothing here saying that we have to respond in scientific notation or not. I actually think that the normal notation makes more sense for these answers. Okay. I was trying to move my screen and move my recording area instead. So the back side of this. Okay. Writing the speed of light in scientific notation, especially if your calculator's in scientific mode, very easy. You're just going to go ahead and type that in and press enter. So this is 1.86 times 10 to the 5th. We should put our units on this, just like every other problem. This is in miles per second. We got our 3 significant digits. That's why I stopped instead of writing all of this out. All right, and then we get the questions that are a little more difficult, the unit conversion type questions. First question here says, okay, the Earth is approximately 93 million miles from the sun. So we know this, 93,000,000. And we could put that in scientific notation. It doesn't matter. This is our miles. We want to know how long does it take. They didn't tell us what units to use for long, but we want to know time-wise, right? Long here means time. How long will it take? So we're going to use this as a conversion. Our speed of light is a conversion. So we need to put the 1.86 times 10 to the 5th down in the bottom because we need our miles to cancel. So if we do this, miles will cancel, we'll be left with seconds. That's the purpose. So we're essentially doing this 93 million divided by the other piece. Again, you could have converted to scientific notation, but I didn't see a point. So 93, 1, 2, 3, 1, 2, 3. You would have had 9.3 times 10 to the 7th if you did. We're just going to divide that by our speed of light. If you do 1.86, you're going to get something slightly different. So we'll do both 1.86 little e to the 5th is one option. We just get 5 times 10 to the 2. if we use 9.3 and we divided it by our original, the 7, and we divided it by the original amount, 1, 8, oops, why did you do this to me? 1,862,82. We get out something a little bit different. So just throwing out that the rounding does matter. So here, let's just write out what our 5 times 10 to the second would be. This is in seconds, right? Because seconds is the only piece left of our units. And if you think about that, this is 500, right? As we add 2 decimals to the end, 500 seconds. And you may even want to convert that into minutes, right? If you want to. 500 seconds is fine. They didn't tell us what units we need. So this is perfect. If you went with the non-rounded version, you would be telling me it was 499 seconds instead of 500 seconds. So not a huge difference, but for science, sometimes that makes a big deal. Our last question, or second to last question here says, how far does light travel in one day? So now here's our starting part. We've been told we have 1 day. And we can see that we're looking for how far. So now we're looking for a length. So again, we're going to use this conversion. Think of our speed of light as a conversion. Unfortunately, our units of time are seconds, and we're now in days. We got to get days into seconds first. So I know a lot of you looked this up, but in 1 day, there are 24 hours. In 1 hour, there are 60 minutes. And in 1 minute, there are 60 seconds. The whole point of this is being able to cancel out days and days, hours and hours, minutes and minutes. So now, once I do all this multiplication, I have how many seconds we're talking about. And if I want to set up this 1.86 times 10 to the 5th miles in every 1 second, now I can have my seconds cancel and I'm just left with miles. I can tell the distance that light has traveled in a day. So this is the whole point of this little stoichiometry, or this dimensional analysis that you see in science, is we're just setting it up so that all of our units cancel. It makes life very easy on us. So I just need to do all that stuff multiplied together. So 24 times 60 times 60 times my speed of light. I'll go ahead and just use the rounded version because I think that's what a lot of you guys did. So we should get out, something way bigger because we haven't just traveled for a second. We've traveled for a whole day. We have 1.61 times 10 to the 10th. Oh, and I should put my units, miles. So a ton of miles traveled. All right. Our last question is asking again about miles, and now it's saying in 1 light year. So the light year is a distance a light will travel in 1 year. So again, we're looking for miles, and they've started us off with this 365.25 days. There are a lot of ways to do this. One is we just figured out how many miles it'll travel in 1 day. So the easiest thing to do instead of redoing all these conversions is just say, oh, this many miles is in 1 day. That's what we just found in part C. So if I just multiply those together, I'll have my answer. So I'll take my previous answer and multiply by 365.25. So we get out 5.87 times 10 to the 12th. All right, so we got 2 last questions on this worksheet. One here tells us assume 20,000 runners are in the New York City Marathon. Each runner runs a distance of 26 miles. Technically, it's 26.2. If you add together the total number of miles for all runners, how many times around the globe will the marathon runners have gone? Consider the circumference of the Earth to be 2.5 times 10 to the fourth miles. So essentially, we want to know, oops, I don't know why I drew that. We want to know how many times would we have gone around the Earth. So one time around is equal to 2.5 times 10 to the fourth miles. That's our conversion. I'm really getting mad at my pen for looking so crappy, but oh well. So that's our conversion that we're going to use. First thing we need to do is figure out, well, what are we dealing with? Well, we're looking for the total number of miles ran. And our total number of miles is 2,000 times 26, right? 26 miles for every one of those 20,000 runners. I think I might have said 2,000, but I meant 20. So 20,000 times 26. Oops. And I'm still in scientific mode, so my calculator is just going to pop this out in scientific mode. 5.2 times 10 to the fifth. 5.2 times 10 to the fifth. And this is the number of miles, right? So again, this is important because we're going to use this conversion to clear this. So we know that there are 2.5 times 10 to the fourth miles. I'm setting it up on the bottom so that my miles will cancel every one time that we go around the Earth. So in this case, miles will cancel. All I need to do is 5.2 times, oops, or 5.2 times 10 to the fifth divided by 2.5 times 10 to the fourth. And before we even get started, we know if we're dividing 10 to the fifth by 10 to the fourth, we should get something around 10 to the first power. So we get 2.08 times 10 to the fourth power. Oh, sorry, 10 to the first power. And that we might as well go ahead and convert, right? If we just have to move this one decimal place, we're looking at 20.8 times around the globe. All right, last one. McDonald's has sold more than 1 billion hamburgers. If it were possible to eat a hamburger every minute of every day without stopping, how many years would it take to eat 1 billion hamburgers? So we need to figure out what parts are conversion and what parts are starting value. So we can kind of figure a little bit of this out. They told us how many years, so we know what we're looking for. Our final answer is going to be in years. And they've told us that we want to start with this 1 billion hamburgers. So somewhere there must be a conversion that gets us from burgers to a time. And that's exactly what we had in the previous thing. We can eat a burger every minute. So that's our setup. 1 burger for 1 minute. And then we need to figure out how many minutes there are in a year so we can continue through our smaller conversions. Well, there are 60 minutes in 1 hour. And there are 24 hours in every day. That's why they said day and night, was to make sure we realize we don't have to sleep. We can continue eating hamburgers. And there are 365. If you want to use the same values that we were given before and take into account leap years, there are 365.25 days in every 1 year. So now we have figured out a way to start with burgers, cancel all the way out until we are left with nothing but years. So this is the math that we need to do. Sorry, I'm going to leave myself more space. All right, so we do need to type in billion. Billion is one more set of those 3 zeros than a million. So a billion is, just so we have it here, that will be 1 million. A billion has an extra set of zeros. So if you write that in scientific notation, this is 1 times 10 to the 9th power. I'm just going to let the calculator do all of it for me. 6, 7, 8, 9. 1 times 10 to the 9th. Multiply by 1. Then I'm going to divide by 60. Divide by 24. Divide by 365.25. And I end up with 1.90 times 10 to the third. And since I want to know how many years it would really take me, I'm going to go ahead and convert that back. We have 1,900 years of eating hamburgers nonstop to get those billion hamburgers done. So anyways, I hope that helps with this worksheet. That's it.